Hi, everyone. Welcome back to the data visualization and image processing track. Now we'll be having Sebastian M. Ernst presenting Plotting is easy, graphics acceleration is hard, let's do videos instead. We'll again have about 10 minutes at the end for Q&A, so take it away.
Thank you very much, and welcome to this presentation. So the title kind of says it all. I want to talk about making videos for more or less scientific visualizations. So this is kind of where I want to start. So why videos? Why is this so important? So in many cases, I actually found through my work that I needed some kind of a middle ground between static plots, like an image, and some hardware-accelerated visualizations, which is also something that you can do with Python, with other systems. It doesn't matter. And I mean, I'm visualizing stuff as part of my work. I'm basically doing freelance scientific software development and high-performance computing stuff. So I'm usually dealing with larger quantities of data for different domains, basically. And sometimes I want to basically have a look into them. And for something like this, really, I usually do not have this much time. For instance, when it's for debugging or when it's for, let's say, showing a client or someone I'm working with quickly some data visualized in a nice way. So a video is kind of the easiest option from my perspective, and it's also the quickest option if you do not have too much time for development. But let's say if you have some raw compute power. So that's kind of the middle ground I'm shooting for. And this was kind of motivating me to look into the entire Python ecosystem and look like, what can you do to make videos? What are the limitations? And like, how do you, let's say, improve the situation a bit? Let's start with the state of the art, basically. So I've done quite a bit of research over the years looking into different plotting libraries and their plotting capabilities and their animation capabilities. But some of the packages that you may have heard of, you can see them on my screen, actually do have animation capabilities built in. So Matplotlib, I guess you all know, this one has built-in animation capabilities. There's even a sub-package within the Matplotlib package, which is kind of assisting in this field. And there are tons of packages built on top of Matplotlib, just naming two, Animatplot and Celluloid. So it's quite common for people to use those packages to simply make a video or even interactive visualizations. So it's something that Matplotlib can do both, basically. But you could also go to other plotting libraries, and again, just naming one example, Plotly. Plotly can in fact animate data to a certain extent. You can refresh the plot. It looks a bit like stop motion, but well, there's a strong strength in this. At least the plot itself is accelerated by WebGL if it's running in a browser. But bottom line is all these stuff that you can see here have plotting as the primary thing and kind of like animating as a secondary. It's kind of just a side effect that you can animate to some extent, but those libraries are not primarily meant for that. And this kind of puts some restraints on what you can do with them. Then in contrast, what do you have where animation comes first? And again, just two, let's say, more well-known examples. One is called Manim. I hope I pronounce it right. It's a package for animating math and teaching math and physics, basically. So the gentleman who wrote this one basically has a YouTube channel, and he needs stuff to animate formulas and stuff like this. It's a wonderful package, but it also has a certain target audience and kind of features that are really tailored to animating math. And this may not be something that you need. Also interesting is Blender, and I see people doing scientific visualizations with Blender quite nicely, but again, Blender is not primarily meant for that. So you may have a tough time animating your plot with Blender if you've never done this before. So again, well, it's cool, but not perfect. Then, well, next on the list is what can you do to just use graphics acceleration? Let's say you have actually large quantities of data and you have the development time available to yourself, then you can use packages like SciPy and Clumpy. But let's say both packages, for instance, assume that you at least know what an OpenGL shader is and how to write some basic C++ and so on and so forth. Now, again, this list is not complete. There are more packages, more or less easy and complicated to use. But bottom line is it takes quite a bit of time to make something specific work with that. And this is something that I've found as a limitation for my workflows in many cases. It's a great library, just looking at the chat. Yes, definitely. So in terms of video the Python ecosystem actually does have some interesting libraries just for working with videos on a lower level. If you already have a video, like MoviePy, for instance, is an advanced nonlinear editing library. So you can kind of cut videos in every way you can imagine, purely based on software. On Python, you don't need a cutting tool for that. Most libraries that I've just mentioned somehow wrap around FFmpeg for encoding, decoding, cutting, whatever. So there's FFmpeg Python, which is an excellent tool for just getting some flow control and managing videos, basically, and cutting them. Last but not least, you also have PyAV, which is more like a low-level binding to FFmpeg. But those are just building blocks, really. You don't have a complete library here for kind of doing all the stuff that you may want to do for making a proper scientific video. So the point is, why a new library then? So I found myself writing pipelines for generating videos, basically, quite often, actually, over the past couple of years for quite different purposes. And I had to rewrite a ton of boilerplate code over and over again. So like just handling FFmpeg and streaming images and whatever. And a lot more, actually. So this is kind of annoying, and I wanted to get rid of the boilerplate code. The second thing, I needed some basic editing and the plotting in one place. I didn't want to generate small videos and then edit them into one thing. I wanted to have a code where I could specify, now I need this plot, now I need that plot, now I need this certain feature. And I wanted to have like one single script with nice readability for exactly that in one place. Then something that may not always be something that you immediately see, but speed and parallelization are a major topic when generating videos. And just generating some simple, let's say, MP4 file with, let's say, 60 frames a second, 10 minutes or something like that, can take quite a bit of time. So you want to parallelize this as good as possible. And again, you may want to abstract this away. You don't want to see the parallelization in action. You simply want to specify your video and plotting code. So this is something that I had not seen before. Then, well, basically, I wanted to use existing plotting libraries, meaning there's no need to reinvent the wheel. I want to use matplotlib. I want to use maybe stuff like Plotly. I want to use data shader quite a bit, actually. And maybe I also want to use some low-level tools like Cairo or PyCairo just for drawing graphic primitives. There's no distinct package in the scientific Python ecosystem which is doing all of that. And this was kind of the motivating factor for me to kind of start one. So next on the list, meet my package. And actually, I would say the easiest example I can think of, minimal example, the package is called bewegung. It's a German word, simply means motion, or actually something that moves, basically. So what you can kind of see, I hope you can probably read it. Otherwise, please go to full screen on your devices, then you may be able to read this properly, is kind of my minimal example, which is also found in the documentation for this package. I will put a link at the end of the presentation. So what you see is I'm importing a video class, basically, and I'm declaring myself a video object where you simply see a width in pixels and a height in pixels. So this is full HD, 1080 by 1920 pixels, basically, and I'm saying I want to have 10 seconds of time in the video. I don't even provide frames per second, so this is something that goes implicitly. I default to 60 frames a second. Underneath, you see a class. Let's say lines 7 down to 12, basically. You see a class with a single method. The class has a decorator, the method has a decorator, and you see something that is called a sequence, and you see something that is called a layer. So keep those terms in mind. Now we have defined ourselves a basic video thing, right? And the code is blurry and a little difficult to read. I have to be honest, I believe I do. Yes, I have HD enabled. Actually, I have a PDF uploaded to this system, so my apologies. Bottom line is the last line, line number 16, if I'm not mistaken, yes, is triggering the rendering of the video. So I have like 3 steps. I define a video object. I define myself something like sequences and layers, and then I tell, okay, now I need to render this down to an MP4 file, right? This is our workflow. So let's talk about the terminology here. We have layers and we have sequences. And this is something that I basically took from graphics editing tools like Inkscape, Adobe Illustrator, or CorelDRAW. Those tools all have layers, basically. So you're stacking stuff on top of each other on your z-axis, like the depth, basically. I wanted to have the ability to define certain backgrounds, and I wanted to have the ability to kind of stack different aspects on top of each other. Maybe I want to have a base plot with matplotlib, and then I want to stack something like basically a data shader output on top of that, or even more. And then I maybe want to use PyCairo for annotations. So you can kind of imagine that this is what the layers are for. Each layer is driven by a backend, and a backend is one of the established Python plotting libraries, basically. So this could be matplotlib or anything else, really. One backend per layer. What is also something that you kind of almost immediately need once you're talking about videos is like some basic visual effects. It's like you want to fade something in, you want to fade something out, you may need a simple transition, which does not look complete crap, but just a bit, and so on and so forth. So this is video effects, which are also handled by the layers. So this is kind of a layer. You can imagine that your video has multiple layers, basically, as many layers as you want. Then the second term, sequences. Remember I told to you about basic editing. So a sequence is kind of constrained by a start and a stop time. And a video can actually have multiple sequences, and those can overlap, meaning that we can define an intro and an outro. And in the meantime, we may have our plot, which does some interesting stuff where stuff is moving around. And then the outro moves over the plot and stuff like that. So this is kind of the idea of having a sequence. Sequence manages the layers. And well, sequences can overlap. We can have as many sequences as we like. And a sequence also does data management for us. So something that, again, with this background of managing large quantities of data is important. I need some layer that kind of imports data or reads it from the hard drive or whatever and makes it available to multiple layers. So multiple layers can share a common data source. So this is kind of the idea of prepare tasks, basically. Let's have a look at a slightly more advanced example. And this is by far not as advanced as you can go with this library, but it kind of shows some of the basic terminology that I've just discussed. So this is again an intro. There are 4 pieces to this demo. And again, it's a demo taken from the documentation of this library in case you want to look it up later. So what you kind of see here is I'm not only importing the video class, I'm importing some other stuff. So I'm importing a color class, which is kind of doing color management for different Python plotting libraries in kind of a way that is harmonized. So you get the same colors in every library if you should mix them. Then there's a vector class. So I'm doing a lot of linear algebra when I'm plotting. So I have some basic linear algebra stuff implemented in here. Then you see some effects being imported, fade in effect, fade out effect, which are classes in my case, and you also get an encoder object. So I'm heavily working with FFmpeg in certain kind of configurations. And you can basically say, hey, I need a GIF file or I need an MP4 file with certain properties, and you simply import an encoder class, which is handling this kind of stuff for you. Next up, you see, again, I am declaring myself a video object. And you basically see, okay, smaller resolution. This time I'm saying how many frames I want to have. I'm not saying 10 seconds. In this case, I'm saying I want to have like 300 frames or something like this at, I believe, 20 frames per second or 30 frames per second, something like this. So this is also something that you can do. At the end, you always have a distinct number of frames. Let's go for the next part. So now we have a video object. We have imported all the stuff. And basically what I'm doing here is I'm playing with the idea of having sequences and layers. So here I'm basically having a sequence that is called background. Sequences are always classes with a certain decorator. And the decorator actually comes from this video object that you have just created. So the video object is kind of the management system for all of that. It holds the data, it holds eventually all the classes which represent the sequences. It will also hold the data. It will take care of parallelizing stuff and so on and so forth. So that's why you always see v.something as decorators here. So the v.sequence, that's our kind of the decorator that is applied to this background class. Within the background class, you see kind of a method that simply gives us a layer. It's an empty layer, hence the stupid name. And on top of that, you have this v.layer decorator, which tells you, okay, we have a certain z index, like in CSS, for instance, and we have a certain canvas with like a background color or something like that. And the canvas then will be eventually passed into this layer method. So the idea is basically that the layer method will be called once per video frame. And basically the canvas will be reinitialized once per video frame based on whatever you tell it to. So this is kind of the thing where you say your canvas is supposed to say a matplotlib figure, or your canvas is supposed to be a data shader aggregation canvas or something like that, or your canvas is supposed to be a PyCairo index. Anyway, so you kind of see that's the idea. The layer methods get called again and again. So basically, next one here is just another sequence. So I'm having an example with two sequences. Actually, they kind of overlap. And this time you see actually in the sequence decorator just on top of the example, here I'm providing a start and a stop time. So I'm basically saying I want to take start like 1 second into the video, and I want to stop at -1 seconds. And because this is Python, -1 second simply means I want to go from the back end of the video 1 second in reverse, basically. So the sequence is supposed to stop like 1 second before the video is stopping. That's kind of the idea what you can do here. You can also put in positive numbers, and then you kind of address it from the beginning of the video. Within this particular sequence, it's some foreground sequence. You can kind of see again a layer method, so something that is being called again and again. This time the layer is additionally decorated. It's not only a layer itself, it also has effects, and this time it has a fade in, fade out effect. So you can imagine you can stack just decorators on top of your layers, and you have a ton of stuff that can basically happen in here. And last but not least, inside I'm using a simple drawing system that I implemented because I found PyCairo too annoying for testing. I implemented kind of a wrapper around PyCairo, which is something that I'm calling the drawing board. And this was kind of simple methods like draw, filled circle, and you basically provide it with coordinates, a radius, and fill color, and you kind of get something onto your drawing board. But you could also go for something like simple as PyCairo or whatever else you want to go for here. So last but not least, we have defined ourselves the video object. We have our two sequence classes with, let's say, a layer each in this case, and the video object is completely configured. Now we can actually render it. And this because I'm saying I want to have a GIF. I want to parallelize this onto as many cores as my CPU has. So I'm using the CPU count function from multiprocessing. And I'm basically providing an encoder because I don't want to go for an MP4, I want to go for something else. So there are those predefined encoder classes. And here I'm providing this encoder object for an animated GIF, basically. So this is what you would get with this piece of code. Some additional features. For debugging, it's always relevant to have still images. You don't want to render an entire video. You want to go for a still image at any point in time in the video and test and see what the output is. So this example kind of gives it away, like how you do it. Video object first, and just a random sequence with an empty layer. So we have some kind of stuff going on. And then instead of rendering the video, you tell the video object to reset itself. And once the video object is resetted, you can request any frame within a video that you want. And basically by doing that, you can either write the frame to your hard disk as a PNG, or you can just extract it as a pillow or PIL object, basically. So the Python image and processing library image format, basically, that you can then take and analyze, process, or just plot and display. Prepare tasks, last but not least, they look very similar to layers. So what you can see here in the lower half of the screen is like a layer again, v.layer. So you see this decorator on top of my method. And just above that, you have v.prepare, which is called a prepare task in my terminology. So I usually found that I need to prepare data per video frame. And let's imagine that my video frame has 5 distinct layers, all doing something with the same data, and I want to prepare the data for this particular video frame once. So the layers can then subsequently do whatever I have prepared, maybe a database access or something like that. So this is called a prepare task. And again, you can have as many prepare tasks as you like. They can simply sit underneath the sequences and manage the data for you. This is kind of the idea for those. It's a neat piece of infrastructure that I found very helpful in my day-to-day work. Mixing backends. Again, I mentioned that I can talk to different libraries, and this example actually shows a sequence with 2 layers. And the upper layer, the background layer, is using my internal system, the drawing board. You don't see anything special. On the lower example, which is called, I believe, accruing sine wave. So this one is supposed to like draw a sine wave that slowly evolves over time. This one is actually done using Matplotlib. And here you can actually see that I'm configuring in line 20 a backend for our canvas. I'm saying this canvas is supposed to be a Matplotlib figure, basically. And I'm also passing in a parameter that you know from Matplotlib. So it's the DPI parameter, essentially. And with that, I kind of get my Matplotlib figure as a canvas, which is then fed into the method underneath. And if you look at the parameters, here you see a time and canvas parameter. The canvas is a Matplotlib figure, and then I can do something to it, like once per video frame, basically, whatever I want. Last example, before I'm almost done with this presentation, I just want to highlight some interesting features that I needed very often, and one feature that I needed was the ability to quickly add backends. As a backend is an established Python plotting library, and I want to have a means to integrate whatever library comes up and whatever is interesting. And my kind of tutorial example is I want to treat NumPy as a plotting library. So NumPy is not a plotting library, but you can still imagine a NumPy array to be a canvas where you can draw on. You can draw using slices and index axis and stuff like that. So you may not be perfectly able to see it, but there's something called a backend base class, basically, and you can derive your own class from that. There's documentation available on how to do that. You basically have to implement up to 4 different methods following a certain kind of pattern, and this kind of allows you to integrate just about any plotting library that you want. And if you have some way of generating PIL image objects, like pillow image objects at the end. So this is what I expect from my backends. I want to have a pillow object back from them for any given layer, for any given frame where this backend is being used. You register the backend at the end in a dictionary, and basically then my system picks it up and you can use it for whatever layer you want. That's kind of the idea here. So this kind of concludes my talk, and we have hopefully 10 minutes left. So if you're interested in the project, you find it on GitHub. So you see the link in here, github.com/plysenborg/bewegung. You can also find documentation on readthedocs.io. So in this case, it's bewegung.readthedocs.io. And should anybody be interested in having a chat with me or discussing this library or feature requests or bugs or whatever during the conference, I've opened a Slack channel called Bewegung. As you can see, it's just like the name of the library. And I'm open to suggestions, wishes, or if you let me know that it blew up, I'm also interested in what happened. Otherwise, find my contact details on the right-hand side. And thank you very much for your attention. And maybe you enjoy this little tool in library.
Great. Thank you, Sebastian. We have about 8 minutes for Q&A. I see we already have 2 questions. The first one was from Michael A. Can the video class determine the correct screen size ratio from the input data so that I could only provide the screen width I want and the height is being calculated?
Basically, the idea is that a layer will always adhere to the size of the video if you don't tell the layer otherwise. So basically, the layer is always maximized to the video, to the video size. But initially, you always have to initialize the video with a certain width and a certain height. So this is something that I cannot determine from anything, really. Maybe I want to have a landscape video, or I want to have I want to flip it for whatever purpose. So there's no distinct aspect ratio that I'm shooting for. You can go for any aspect ratio that you want. So basically, you always have to provide a width and a height. By the way, there's a question in chat. If you want to see actual videos, I don't know if the system is capable of doing that, but if you go to the readthedocs.io documentation, there's a gallery inside where I actually have sample videos, and you can just look at them on YouTube, basically. I hope this answers the question. Yes, exactly, gallery in the chat. Thank you very much.
Cool. Are there any other questions?
just looking at a chat, it's better than exporting PNGs and merging them with FFmpeg. Well, that's precisely what I guess most people have been doing for the past years. And again, this is also what I have been doing. And I want to get rid of this kind of step, and I wanted to have a clean solution for precisely what you just wrote in the chat.
Okay, cool. Thank you for the presentation then. Really cool tool.
And thank you very much. If you're interested in this, please find me around. And if you're interested in this library, I'm always happy to see issues, bug reports, pull requests, ideas, whatever you like.